Hello all, welcome back. Now, I'm sure. Now I am showing you how I have generated the time series data using LSTM neural network. For this LSTM neural network, I have designed the architecture as you can see here. So in this architecture, we can see that there are five hidden layers and one input layer and one output layer. So in these five hidden layers, three of them are LSTM layers and two of them are dropout layers. So using these five hidden layers, uh, the input layer, I have processed the input to produce an output from the output layer. And the core parameters that I have used for this LSTM neural network are I have used 20% as the testing data percentage and with three LSTM layers. And each LSTM layer has 15 neurons in it. And I have designed with two dropout layers with the dropout percentage as 20%. And I have also took 60 as the length of the time series input sequence to generate a data point. Uh, the batch size for testing and forecasting is 1, and the batch size for the training is 32. Uh, and I have took 100 as the number of epochs that I will be using for the training. And and this is the coding results that I have obtained when I have ran the LSTM with time series data. So firstly, I have imported necessary libraries for visualization for RNN LSTM neural network, and I have imported Keras time series generator and Minmax Taylor. I have used Samsung electronic stock data for this analysis. And the shape of the data set is 1,239 observations with 7 columns. As we can see, the snapshot attached there. Even we can observe that the closing values have been increasing slowly after a clear drop from the image from the image that I have attached in the bottom. So I built the LSTM model with setting the number of futures to 1 and define the model with 3 LSTM layers, 2 dropout layers, and a fully connected layer. After building the model, I compiled it with Adam Optimizer and MSE as loss value. During training of the model, we trained the model for 100 epochs and we have resulted some loss. During these 100 epochs, the highest loss is 0.0184 as we can see the visualization which I have attached here. So after that, I forecasted the data for next 20 business days, which is from 10/31/2023 to 11/20/2023. Using for loop, I have stored all the predictions. Later, I transformed the normalized values into the true values and created a new timestamp indexes with pandas for 10/31/2023 to 11/20/2023. This is the result of those 20 data points of the actual close values and the forecasted close values. The blue line indicates actual values and orange line indicates the forecasted values. For the first 2 or 3 data points, maybe the actual and forecasted values are a little bit close to each other. Whereas later we can see that both the lines are traveling far from each other, making far from each other. With this, we can say that there is some difference between each other and our LSTM model can be better and more accurate. Uh, so I have redesigned the LSTM for the time series data. This time I have increased the number of hidden layers from 5 to 7, indicating I will be using 4 of the LSTM layers and 3 of the dropout layers with 1 input layer and 1 output layer. So the list of the crucial relevant parameters that I have used for this redesign network are 30% of the testing data percent. And I have used for LSTM layers that I have said earlier. With each LSTM layer, I have took 16 neurons. So for the before part, I took 50 neurons for each LSTM layer. So now I have increased the count of neurons from 50 to 60. And even I have increased the dropout layers count from 2 to 3 And also the dropout layer percentage is 30% this time. And the length of the input sequence this time is 50, with the batch size as 32 for the training. And the number of epochs I have used for this training is 100. So even this time also, firstly, I have imported necessary libraries for visualization. And for RNN LSTM neural network, I have imported Keras, time series generator, and min-max scaler. Even I have used Samsung Electronics stock data for this LSTM model also. And the heap of this data set is 1,239 observations with 7 columns, as we can see in a snapshot. And the visualization of the close values of this Samsung electronic stock data is the bottom of the slide. And I build the LSTM model with setting the number of features to 1 and define the model with 4 LSTM layers, 3 dropout layers, and a fully connected layer. After building the model, I have compiled it with Adam Optimizer and MSE as loss value. During training of this model, I trained the model with 100 epochs, and we have resulted some loss, and the highest loss being is 0.1109, as you can see in the visualization I have attached in this slide. After that, I forecasted the data for the next 20 business days, which is from 10/31/2023 to 11/2023. And using for loop, I have stored all these predictions for the next 20 business days. Later, I have transformed them, the values in true values, and created new timestamp indexes with pandas. And this is the result I have obtained for the 20 data points, looking at the actual close values and the forecasted close values. The blue line indicates here the actual close values, and the orange line indicates the predicted close values or the forecasted close values. For the first 2 or 3 data points, here also the actual and forecasted close values are closer to each other, whereas later we can see that both the lines are traveling far from each other. With this, we can say that there is some difference between each other, and our LSTM model can be better and more accurate. And also, I can say that the redesign model didn't perform well as we thought than the before LSTM model, even though I have increased the number of neurons. So now comparing the LSTM RNN performance of the part 4 and part 5, like the LSTM neural network and the redesigned LSTM neural network. If we look at the final forecast result and actual close value plots of part 4 and part 5, we can say that even with the increase in the number of LSTM layers and the dropout layers, and increasing the testing data percentage to get the model more validated, and even increasing in the dropout percentage, the final result of these 2 neural networks resulted almost same to each other. So maybe as I have decreased the number of neurons from 60 to 50, in the redesign network, the performance looks same, even though LSTM layer and the dropout layer has increased. From this, we can analyze that number of neurons present in our layers is a key factor. We can consider improving our model's performance and accuracy. Overall, we can conclude that our redesigned neural network resulted in no significant change in the performance, even though the LSTM layers and dropout layers has been increased. And we can say that the number of neurons used in the model is very important, keeping aside how many number of LSTM and dropout layers that we use for our model's performance. So coming to the total project report, the primary objective of this project is to explore the recurrent neural networks for sequence data interfering with the deep learning. Sequence data is nothing but any data that is present in an order or any elements that are present in an order. It is not an easy task for us to handle these types of sequence data with simple neural networks. So to do these kinds of data, we have deep learning algorithms and recurrent neural networks, which can enhance the results. We all know that deep learning is a part of machine learning, which is used to make major decisions based on the instructions that are passed to the model, which is the main reason that brought the breakthrough for the deep learning. In this total whole project, as I have said earlier, we have used TensorFlow, Keras, time series generator, and min-max scalar libraries to train, build, transform the recurrent neural networks that we have built to know the accuracy levels and the performance. And all the coding part for this project is done in the virtual machines Jupyter Notebook. Uh, and we have used recurrent LSTM neural networks to design this model, as this machine learning algorithm is most used for analyzing sequential data. And I will explain the things that we have done in the final project in all the parts, such as the second part, third, fourth, and fifth part. So in part two, I have so why I am saying all this is I want to give the brief explanation of what I have done in the total project. So in the part two, I have designed a simple recurrent neural network and explained the design. I have generated sine wave data using simple recurrent neural networks. And in the process, I have used Jupyter Notebook to run the code. And for that, I took the range of the index from 0 to 59 with 1013 data points. And I said earlier, I have took the neurons as 75 to the sine wave data. First, before building the model, we split the data with 20% testing data and then normalize the data. After building the simple RNN model, we compile the model using Adden optimizer and loss function as MSE, and I fit the model using 5 epochs. Later, I have evaluated the testing data and then made predictions and generated the sine wave data plot with actual and predicted value. And from the plot, I have also found that the model performed very well, seeing the low error values between the actual and predicted values. And coming to the part two, in the part three, I have explained clearly about vanishing gradient problem, exploding gradient problem, and how does this problem occurs, and what are the steps that we need to take to prevent these gradient problems. And later, I have also explained the limitations of the simple recurrent neural networks and how LSTM neural networks can provide the powerful solutions to both of these limitations that I have in the simple RNA neural networks, and also to the problems that we encounter, such as gradient problems. And coming to the part four, in part four, I have designed LSTM neural network with one input layer, three LSTM layers, two dropout layers, one output layer. Later, I have logged on to the virtual machine and then opened the Jupyter Notebook. I have also used LSTM for this time series data and took around 5 years of period of time of Samsung electronic stocks data. And after building the LSTM neural network using Keras sequential model, I have trained it and tested the model. Later, I have retrained the model using the whole data and prepared it to forecast the future close values for the next 20 business days and perform the forecast using retrained model. And our model got some different results of data points for the actual and predicted values. And I felt that our model could perform better than how it performed. And in the part five, where I have redesigned the LSTM neural network to see whether the performance may increase when you have redesigned. In this redesigned neural network, I have increased the LSTM layers count from 3 to 4, and the dropout count from 2 to 3. And as I have said earlier, I have used the same Samsung electronic stock data for this model also. So after building the LSTM neural network using Keras, I have written the model using the whole data and prepared it to forecast the future business 20 days. And even in this design neural network also, I have seen there is some difference between the forecast close values and the actual close values. And I have thought that this model can perform more better because as I have redesigned, I would have thought of some improvement in the performance, which I haven't seen during this redesign. So, so from overall, the things that I have learned is from this project is that a simple RNN LSTM neural networks can predict are majorly used to predict sequential data and time series data, as these are the main networks that can handle sequential data. I have also learned that there are some gradient problems, and this limits the ability of the neural networks to learn. So the other thing I learned is that with a greater number of neurons present in a neural network can help our model to perform better. And also sometimes, even if a greater number of layers cannot increase the performance of our LSTM neural networks. So overall conclusion I have obtained from this project is that using all of these concepts, such as LSTM neural networks, simple RNN neural networks, short-term memory and gradient problems have been fascinating because these are the latest technologies and to get hands-on experience. And I can clearly conclude that practicing and learning these can shape our knowledge well, and it showed us what major contributions we can make for the society that bring an impact using these technologies. Uh, thank you. So thank you. This is the end of my project presentation, and I hope everyone enjoyed it. Thank you so much.